This video is the continuation of the lesson for class 10th for the subject of chemistry, topic electrolytic refining of metals, which is covered in chapter 6 electrolysis and is being submitted to you on 5th July 2021. So students, in the second video we will discuss the electrolytic refining of metals. Now we will do the refining of metals. So firstly you tell me what is the meaning of refining. Refining is that process through which you can remove the impurities from the metals, right? So let us discuss it. So students, electrolysis has many applications, means many used. In the last topic we studied about electroplating, and now we will study about refining of metals using electrolysis. So the metals are extracted from the ores that you have already studied in the 9th class. The metal after separation from its ore may still contain some small impurities like other metals or non-metals. So removing these impurities is called as refining, and when refining is done with the help of electrolysis, it is called as electrolytic refining. I hope you have understood that. Now we will do the refining of copper. So here we have already set the apparatus. From in the container we have taken the electrolytes, which is a copper sulfate solution and sulfuric acid, right? In the left hand side we will take the pure copper strip, which is a negative charge, which is of cathode, and it is attached with battery and ammeter. And in the right hand side there is a positive charge anode, which is a slab of impure copper, right? So impure copper is refined by electrolysis to remove small amounts of impurities present in it. So what we will do here, we will refining the copper, impure copper, right? Meaning we will remove the impurities from the impure copper. So have you seen this apparatus? Now we will discuss the process of this. So let us open the page number 6 of the notes. So same, we will do the dissociation of electrolytes first. Here's this USO4. We will dissociate the Cu2 positive plus SO42 negative. Water is dissociate as H positive, OH negative, as you all know. And sulfuric acid is 2H positive plus SO42 negative, right? So, what is the cation produced and anion produced here? As you know, cations produce Cu2 positive and H positive, and anion produces SO42 negative and OH negative. I hope that this portion you have already understood very much clearly, because we have done it so many times, right? Now we will do the reaction at cathode. What will be the reaction at cathode? As you know, where is the cathode is present? It is in the left hand side, as you observe the diagram, which is of pure copper. Okay, so what will be the reaction over here? So in preference to H positive ion, Cu2 positive ion get reduced in cathode, right? Cu2 positive will take 2 electrons and will become Cu and will become reduction. So reddish brown copper starts depositing at cathode, then thin strip become thick slowly. And reaction at anode, both sulfate and OH negative, which is SO42 negative and OH negative ions migrate, means they will move from their position to anode side, but do not get discharged because copper from the impure slabs get oxidized as its oxidizing capacity is higher, right? So what will be? Copper will lose 2 electrons and will become Cu2 positive. Okay? When the element will lose electron, the oxidation will take place, and when the element will gain electron, the reduction will take place, right? That you have already know. Now we will do that slowly the anode starts dissolving and it becomes thin, because copper is continuously changing into Cu2 positive ions and getting deposited at cathode. Thus, all the pure copper from anode is transferred to cathode. Some impurities get dissolved and some get deposited at the bottom of anode, which is called anode mud. As you may observe in the diagram, here, this black part is a anode mud. So what will we will, after doing the whole process, the refining of copper will be done. This is showing the anode mud, which is the impurities left. Now we will do the next topic, which is very, very important, which is electrometallurgy. So what is electrometallurgy? So students, metals are not present in pure form in nature. They react with other elements to form compounds which are present in ores. Metals are separated from their ores by the process of metallurgy. So reactive metal, which is potassium, sodium, calcium, magnesium, aluminium, as you know, we have done the reactivity series through which they are the reactive metals, okay, which are higher in the electrochemical series, form very stable compounds. Their oxides are also very stable as they have a strong affinity for oxygen and form a strong bond with it. These oxides cannot be reduced by reacting them with reducing agents like CO, which is a carbon monoxides, and H2. Thus, these metals are extracted with the help of electrolysis. This is only called electrometallurgy. So here is the diagram is drawn, in which we have taken the one is a cathode, which is of iron, and second one is a anode, which is of graphite, inert electrode. And electrolyte, we will take the molten potassium bromide, right? So reactive metal react with halogens. Okay, like what are the halogens? Like chlorine, bromine, iodine, right? जो reactive metal होगा वो आपका किसके साथ react करेगा? Halogens के साथ, और they will form the stable halides which are present in their ores. For example, potassium can be extracted from KBr only by its electrolysis. Here we have done the electrolysis. When we will do the electrolysis of KBr, it will dissociate into K positive and Br negative. So it will be easy for the metal iron to get react. So the reaction, cathode reaction, is what will happen? The potassium will take one electron and will become potassium K, right? And potassium deposited on cathode. What would be the reaction on the anode side? Bromine will lose one electron, which will become Br, and Br plus Br again, they will become Br2, reddish brown fumes at anode. Note: the reactive metal salt should be in a molten state and not in aqueous state dissolved in water, which means because then water will ionize and H positive ion will get discharged in preference to metal ions. To separate sodium from NaCl, the electrolyte will be molten NaCl. In molten state, NaCl dissociates to produce NaCl, Na positive, Cl negative. On passing current through electrolyte, Na positive ions migrate towards cathode and Cl ions migrate towards anode. Here you may observe this by the reaction. At cathode, sodium will take one electron and will become Na, and sodium deposited at cathode, and at anode, chlorine will give one electron, lose one electron, it will become Cl. Again the Cl plus Cl, it will need one molecule of chlorine to become one atom of chlorine to become molecule, and it will become Cl2, which is a greenish yellow gas at anode. To separate magnesium from MgCl2, molten MgCl2 is taken as electrolyte. In molten state, it will dissociate to produce MgCl2, which is Mg2 positive and 2Cl negative. On passing current, Mg2 positive ions migrate towards anode. At cathode and anode, you may observe the reaction on the page number 9 of the notes, which is sent on 5th July 2021. Therefore, we see that any metal can be separated from its compounds by electrolysis. Now, I will give you three very short questions. You will get a 3 minutes break to write the answers in your chemistry notebook. So, the questions are: Question number 1. Name the metals which are used for thin coating in electroplating with other metals. Question number 2. When the refining is done with the help of electrolysis, it is called as dash, which is a fill in the blank. You have to fill the blank. Now the last question number 3 is, in molten state NaCl dissociates to produce. Now pause your audio for 3 minutes and write the answers in your chemistry notebook. I hope you all have written the answers by now. Let us check the answers now. Answer number 1 is gold, silver, chromium, nickel, etc. Answer number 2 is electrolytic refining. And the last answer number 3 is NaCl will dissociate into Na positive and Cl negative ion. Now I am ending the lesson for today by giving instructions and homework. So instructions and homework are, students are advised to read the topic from book, then from the given notes carefully, and do homework from exercise 6 given on page number 117. Do questions 1, 2, 3, 4, 5, 6 and 7. Thank you and have a nice day to all of you.